Hi, I want to talk about acceleration a little bit. So, as we know, acceleration is a vector, therefore it's going to be defined by magnitude and direction. So, acceleration by definition is the change of velocity in time. So, this delta, whenever you see a delta in front of a parameter, stands for change of that parameter. Therefore, whenever you see it, you can replace it with the final value minus the initial value of that parameter. So t delta t is t minus t0. So this t naught or t0, v naught, v0. These are the initial values of these parameters, and these are the final ones. For general purposes in physics, we just take time, initial time to be 0. So you get basically this well-known formula for velocity is equal to initial velocity plus a times t formula. You probably had seen this one before. So if you rearrange these terms, multiply both sides with t and take the v0 to the other side, you get this formula. And from here, you can see that the direction-wise, there's a relation between the velocity at a given moment and the acceleration that is basically the object is experiencing. So, for example, let's say you have a car that just started with the initial velocity of 0 with an acceleration of, I don't know, 10 meters per second square. So because the acceleration is change in velocity, and if you look at here, it is meter per second for the velocity, right? That's the unit of velocity. Divided by second, it's going to be meter divided by second square. And so, whenever you say acceleration, you should look for the unit as meter per second square, basically. And if this object is accelerating with 10 meter per second square, it basically tells you every second it's going to get faster by 10 meter per second. So basically, starting from rest, because the initial value for the velocity was 0, 1 second later, what you will have is that velocity going to be 0 plus 10 times 1, right? Which makes sense because, what did I say? Just when I talked about acceleration value, every second the velocity is going to increase by 10. So that makes sense because after 1 second, this is how much it's going to increase. After 2 seconds, I guess you can guess, v is going to be equal to 0 plus 10 times 2. So it's going to be 20 meters per second, right? So this is after 1 second, this is after 2 seconds, and it goes like this, so you can guess the rest. This is when they are in the same direction, right? A is positive, therefore, basically it is increasing the velocity in the direction of the A, so your object is being accelerated in this positive direction. If you have an object, this was, let's say, example 1. There is another example we can go over just to discuss the directions of velocity and acceleration. So if your object had actually some velocity before you started the observation, so at the time, like let's say you're timing this motion and observing the velocity values, the data you're collecting, with the velocity, the first moment that you observe was, let's say, 50 meters per second. And I'm going to give you acceleration the same value, which is 10, but this time I'm going to make it negative. Meter per second square. Once again, your velocity is going to change by 10 every second, but this time it is applied in the opposite direction, right? Because the velocity is given in positive, acceleration is negative. Therefore, your acceleration is going to be in the opposite direction, meaning that it's going to affect your object in the opposite direction. So if you solve your equation for this situation after 1 second, you're going to have 50 plus, I'm applying this formula that we just wrote up here. So a times t, right? v0 plus a times t. This is what I'm applying here. So a is minus 10 times 1. And you know what is 50 plus minus means minus, so it's going to be 50 minus 10. Therefore, it is 40 meters per second, right? So After 2 seconds, what's going to happen? V2 is going to be 50 plus minus 10 times 2, right? Because after 2 seconds I'm calculating. So this is going to be 50 minus 20, so it's going to be 30 meter per second. And it goes like this, and you can see that at some point your velocity is going to be 0, right? Can you guess when is it going to be 0? I guess you can guess because 50 minus 50 is going to be 0, and that needs to be 50. Your time needs to be 5 seconds, right? Let's look at it. 5 seconds is going to give you 50 plus minus 10 times 5. And therefore, your velocity is going to be 0. This is the moment that your object is returning backwards. If you keep this motion, observe this motion, after 6 seconds, what is going to happen? It's getting interesting here, right? So, I'm sorry, I wrote V2 here, which should have been V5. And this is going to be V6. I was just numbering with the seconds, so I forgot, sorry. So this is 6. After 6 seconds, what you get is that V0 was 50 minus 10 times 6. As you can see, your velocity is now in the opposite direction, right? It's going with 10 toward left. If your sign is designating like toward right is positive, then it means toward left is negative, right? That's what it means. Your object was moving toward right, but it was experiencing an acceleration toward left, which is basically a deceleration at the beginning then, right? Until the 5th second, it's decelerating, it's slowing down and reach to 0. And then it returns backwards and starts accelerating in the negative direction, okay? So if you calculate the 7th second, what you will see is going to be even more speed going to be added, right? So V7 is going to be 50 plus minus 10 times 7. That 7 looks weird. So your 7s are going to be 70 and 50, so it's going to be minus 20. Right, so your object after 5th second starts to accelerate in the leftward direction, so it's going to get faster and faster in that direction. Okay, so basically, so you have a constant acceleration in the opposite direction to your initial velocity. That's why I wanted you to go ahead and look at the simulation that I attached on the weekly guide as well, to see how the graphs are looking like when you have this situation. Because positive is generally an easy case, but positive negative makes it a bit more complicated. It's not that much, but it looks different, so it's better to look at the graph, or you can draw the graph with these numbers that I'm just providing you right now. So you can draw a graph of velocity versus time graph by just looking at these data, right? 1 second, 40, 2 seconds, 30, 5 seconds, 0. You can calculate like 3 seconds, 4 seconds, all of them, and draw the graph yourself on the paper even, or on the Excel, and look at the graph. But the simulation basically does it for you directly, so you can use the simulation, which is going to save you time. So there are different, 2 more different scenarios, right? This was like positive, negative, positive, positive, and there's like negative, negative, and negative, positive. So you can do the calculations for them too. I just want to point out that if they have opposite signs in any way, make sure that you're counting them in your equation. You can't just look at the number and then write the number like that, because it is basically not going to be correct, and you're not going to come to the right conclusion at the end of your calculation. So once again, the signs in physics are used for direction. So don't forget about that, and you have to be able to implement that in your equations like this. And I hope this helps in your calculations and in your homeworks. Have a good day.